Hello everyone. Today we will solve a resultant problem. Here the problem states the resultant R, which is this one, equals 60 pound shown in figure 36 is the resultant of the 20 pound and 30 pound forces and another force F which we don't know which way it will go, that we'll have to calculate what is the force F. So we will find the magnitude of the force F and the angle of it. So first we will divide all the angled forces to major axes. For that, for the 20 pound we will get a vertical and a horizontal force, and for the 30 pound we will also get a horizontal and a vertical force. And now let's calculate the forces. For that we will start with the horizontal forces. If all the forces acting on this point doesn't move this point, then it's in an equilibrium state. So let's take summation of f of x, and we will take the rightward direction as positive equal 0. Equals, for this we will get a 30 degree. So we can write it down as 20 cos 30 degree, and for the 30 pound it will also go at the rightward direction, so it's a positive one. So we will get 30, and as we can see the angle with the horizontal axis we don't know, but we know the vertical axis of it as 30 degree, so we will write as sine 30 plus f, which we don't know, equals 0. So we can write f equals 20 cos 30 plus 30 sine 30. Then we get 32.32. So we can write minus 32.32 pound. And then for the summation of all the vertical forces we can write f of y and take the upward direction as positive equals 0. Then we can write for the 20 pound we know the horizontal axis has a 30 degree angle with the force, so we don't know this angle. We can write it as 20 pound sine 30. Here we are taking, when the angle is with the horizontal axis and we want the horizontal axis, then we use cos, and when we are taking the opposite one we will use sine. That's how we are changing between sine and cos. So here 20 sine 30 degree, as it is upward so it's positive, and then for the 30 pound it's negative because it's pushing it downward, so minus 30. As we can see the angle is with the vertical axis, so we will write cos 30, and then our resultant R, and it's also pushing it downward and it's not in an angle, so we will write it as it is, R, or we can write directly as the force's value, which is 60, plus F, which we don't know, equals 0. Then we can write it as 20 sine 30 minus 30 cos 30 minus 60. We get 75.98. So we can write F equals 75.98 pound. And if we draw a diagram for it, then we will get something like this. Because the horizontal axis is at negative, so it will push the things at this point, and this is 32.32. And because the vertical force is positive, so it will pull it upward. So we will get 75.98. So for these two forces, we will find the resultant, which is our desired force F. So we can write it as F, and if we want to distinguish the forces, we can write it as X portion, and this is Y portion. So we can write F is equal to root over F x1 square plus F y1 square. Then we can write root over minus 32.32 whole square plus 75.98 whole square, and if we put the values in and calculate it, we will get root over 32.32 whole square plus 75.98 whole square. We get 82.568 or 57. 82.57 pound. And for the angle theta equals tan inverse the vertical portion of the force and the horizontal portion of the force. And if we put the values in, then we get tan inverse Fy1, which is 75.98, and x1, and we use the negative portion or the negative value because we were indicating the direction for the value of theta, which is the angle. We don't need the negative value because we are not indicating any direction, we are just needing the magnitude. So we will use 32.32. Then we get tan inverse 75.98 divided by 32.32. We get 66.96. 66.96 degree. So if we want to visualize the force F, then we can draw it this way. Here this is the R, and this is the 20-pound force which is angled at an 30 degree with the horizontal axis, and for the 30-pound force which is angled with the vertical axis at 30 degree, and for this force it will pull it upward or this direction, and here this is the F and this is the theta. So that's it for this problem. Thanks for watching.